In this problem, problem 2 from Superquiz 3, we're told that, oh my goodness, my kitchen sink is dripping water. Oh, guys, I'll be right back. All right, so the sink is dripping water into the storage area below, and the rate at which it's dripping is decreasing over time and is given by the function f of t equals 1 over t cubed, where the units are cups per minute. And we want to know how much total water will drip starting at t equals 2. So we're given a rate, and we want to know over time how much we accumulate. All right, so this is a perfect instance where we should be using an accumulation function, i.e. an integral. So let's write down that the total water dripping, or dripped maybe that's better, total water dripped, past tense, starting at t equals 2, all right, is given by, it's going to be an integral. We're starting at t equals 2, so let's do that. And until when? Well, we don't know until when, so we just have to go off to infinity, right? That'll be the total amount, right? If we knew that I stopped the drip, 8 minutes later, we could stop it at 10, but since we don't know that, we'll just go to infinity. And now I want to accumulate the rate of change function. So this was 1 over t cubed times dt. All right, so this is an improper integral. We're going to need to find an antiderivative. That shouldn't be too much of a chore. Let's call this, we actually already have a name for it, f of t, right? So I guess I don't have to name that. So what do we got? An antiderivative, gosh, it's really hard for me to view things in fraction form. Let me rewrite it like that. Okay, so an antiderivative is I'm going to add 1 to the exponent and then divide by the new exponent. And now I need to evaluate between 2 and infinity. All right. Now remember, we can't actually evaluate at infinity, right? We are taking the limit as the input goes to infinity, okay? But we're saving a little bit of space here. Oh, I guess maybe again I'll put it back into this form because it's easier for me to plug things in when this t's on the bottom. So I have a negative 1 over 2t squared from 2 to infinity. Now, as t goes to infinity, we are not going to say t equals infinity, but as t goes to infinity, well, this denominator goes to infinity, which means that this fraction goes to 0. All right. Now, a lot of times your instructors are going to get mad if you just write it this way, so I'll show you the so-called correct way to write it in a moment. Okay, then we're going to subtract what happens when t equals 2. At t equals 2, let's see, a minus minus becomes a plus. 1 over 2 times 2 squared is 1 over 8. Okay, and so we end up with 1/8. Well, let's see, what were our units? Yes, cups per minute. So this is going to be 1/8 cups, right? That'll be our units. Okay, that's not the worst thing in the world to end up under my sink. Okay, now for the teachers who are going to require you to write this out in full, all right? How would they maybe expect you to do this? Well, when you say 1 over 2t squared from 2 to infinity, right? What they really want you to do is take a limit as, I don't know, we'll call it b goes to infinity, negative 1 over 2t squared from 2 to b. All right, and then, okay, we'll leave this limit lying around, and you establish what happens when you evaluate negative 1 over 2t squared from 2 to b, which would be negative 1 over 2b squared minus minus, okay, is plus 1 over 8. And at this point, you'd say, okay, cool, as b goes to infinity, this piece goes to 0, and so this is equal to 1 over 8. All right. Why do they want you to show all this extra detail when I wouldn't do it over here? Mostly because they want you to demonstrate that you actually know there's a limit going on, right? That you can't just put infinity into t as a number, all right? As you develop within mathematics, though, and you get to where, well, nobody's checking over your shoulder, as long as you understand what it is you're doing, it's perfectly fine to be able to write things like this. All right, hope this helps.